So
Okay.
hi everyone, I'm Justyna Semba and I'm an employer branding manager in Poland. I'm very happy to welcome you on today's webinar with David Santana, and the topic is Java still relevant? If you have any questions during the presentation or after, please use the Q&A section and press the button to ask the question to our presenter. I hope you will enjoy today's presentation, and I will pass the voice now to David. David, could you please introduce yourself also in a few words to our participants?
Yes, sure. So thank you,
Thanks. So enjoy
everyone.
the presentation, everyone. Sorry.
Thank you. So my name is David Santana. I'm software architect and project manager for software as well. I have been working in the industry of software for more than 14 years. And among all these years, I have been switching different languages, but I'm always stick at least to one, which is Java. And during the last years, especially the last two, I have been wondering why the people are not talking about Java that long as before, and why it's not so trendy anymore. So I was actually checking, is it Java still relevant or not? And I was discussing with some colleagues, and we start to gather information about the development of the language, and just to realize that the Java language right now it's super powerful. And maybe the problem is that there are many other languages with better PR, I guess. So one of the things that I would like to achieve during today's lesson is to show you exactly how has the evolution of the language been, and you can decide by yourself if Java is still relevant for you or not. Maybe another important thing for you to know is that I have been working with different companies during these years, not only here in Europe, but also in North America and in South America, where I come from. And more or less, the projects are very similar. And usually we will discuss today things that are not exactly about methods and libraries in Java, but also one consideration that is maybe for me the most important from my architecture perspective, that is when you should use which technology. So this will be based not only in my knowledge, but also in the experience of my colleagues with whom I've been working in these companies that you can see here. And my idea is to spread this word with you. But my expectations are not just to just present this data, because data is there. You can actually Bing it or Google it or DuckDuckGo it or whatever. But the important fact here is that we are going to do this short reflection. Maybe we will continue this conversation in a second time with deeper technical details. But what I want to do here is that if you are already working in Java, you can also share us why Java is relevant for you. And if you are not Java, why you were not considering Java. If you were Java and not anymore Java, why in this case is Java not relevant for you? So we can understand to this, yeah, with a critical mind, what is happening in the real world, how can we help each other? Good. If you want to reach me out, then you can always do it via my email or here, Facebook or Twitter, or my all accounts are related David DLPS, so no problem there. Why we are doing this, as I mentioned, the idea for me is not only to show you data that you can actually Google, but to transmit the experiences of my colleagues that have been working with me for several years, and some of them actually more than 40 years in the industry. It means that they are from the very beginning. So I got all these different point of views, and I want to show you here that at the moment. Before that, then I would like to know if you can hear me well, if you can see the presentation well, maybe where are you coming from? I mean, which projects, which country, etc. here in the chat. So then we can know a bit better. Here the chat is not enabled. Okay, so no problem. Let me check. Now, yeah, now it's enabled, right? Okay. So while you introduce yourselves there in the chat, I will continue explaining this about this point of view or viewpoint. So Java and in general programming languages and in general software is a huge thema, let's say. So what we are going to do here is to try to scratch the face with the resources we have from our point of view. But of course, we need some restrictions to evaluate that. Otherwise, it will be just opinions. And this is what is going to construct our point of view. From the resources we have and from the projects we have been working in, then why we should use Java, or if is it Java still relevant, or is it still trendy or not. And also we need to analyze different boundaries where we should find Java, because for example 30 years ago Java was not there, and programming languages, let's say oriented object programming languages were not that popular, and the libraries were not that compact and easy to go as today. So at some point when Java was first doing the let's say appear in the market, it was more like academy stuff. But with the time, it started to move more into the professional sphere. Then when with professionals were more like let's say confident, then some governments decide to invite them, invest there, sorry. And then after that, the companies as well. So here we have different perceptions, but you can always check the statistics. If you check the statistics during the last 25 years, Java has been always in the top 10 of the languages during the each of these 25 years. This says a lot in technology, because you know that technology is something that changed a lot in every single aspect. So just to keep 2 or 3 times in the top, that will be just amazing. And here in this case, it's like 25 times in the top. That means that Java is doing something well. Of course, it has its limitation. We are going to see that now. It's not that easy peasy to get, because it's a very condensed, compact language with full with a wide range of functionalities, thousands of libraries, hundreds of frameworks. So the learning curve is not that easy as with many other new trendy languages, but you have to consider here if it's still relevant or not easy, if it's easy to learn or not. So I would like to share with you this information and maybe take you out of your comfort zone so you can evaluate that and decide for yourself if actually Java could work for you or not. Good. I see here people are already introducing themselves. I see Manuel. I see Pavel, Christoph. Good. Nice to meet you all. Let's start from the beginning, where we should do the election of the Java, or in general of a programming language. The programming language should not be the first selection that we should do, because first we need to understand our project. So if you were following me and our previous conversations here, we were talking about project tools, programming tools, frameworks, even way to do Scrum and so on. But we mentioned that the most important for the project in software is to recognize that our specific field of software is not only science, it's also art. And we need to know how can we deal with this uncertainty and how can we control our projects. So for the sake of this presentation, then we will use usually the use cases that are happening most of the time here in Europe, but this can be extrapolated to different regions. If you are seeing us from different regions, feel welcome to make your comments and to know, yeah, and also your perceptions. We're going to work what kind of projects could be Java projects and what we should consider in that. Okay, so before we start, I would like to make you some questions here I mean, in the slides, I'm going to present you the questions, but I'm going to do that here through the poll to see what is your perception just now before the start this conversation, and then we will see at the end of the presentation if your perception is still the same or not. So the first question is, how strong or useful you think Java will be in 5 years? I mean, in 4 in this case, in 2025. So if you're seeing this in this 2020, then how do you think this Java will be in 2025? You think that actually someone is going to use this, or it will not be even in the top 10 in that time, or will be only relevant for legacy and migration projects, or I don't know, maybe it's still super relevant, maybe it's still in top 10 in the 2025. So it means that it will be almost 30 years leading. What do you think about that? These questions, you can, let me finish all these questions and then you can click in the webinar. There is a button that says polls. So I will create a poll after I finish these slides, and then you can just vote there and we can gather this information and present to you. So you can have also a perception of data that you trust in because it's your own data, it's data of your own, of our own community. Do you think that Java is heavy? Yeah, Java is super good, whatever, but it's heavy. You think that in compared to these other trendy languages that we have today, PHP, Ruby, Python, whatever, JavaScript, Go, you think that actually Java is, yeah, good, but 10 times heavier, or mm, yeah, it's so heavy that it's 10 times slower than these languages, or to learn, or in which area? Yeah, so, or it's just, yeah, it's heavy, yeah, like 5 to 7 times, but no, not 10 times, or yeah, it's just heavy but not that much, or yeah, it's more or less the same, like basically 1 to 1, maybe 2 to 1, but not so. Or you think, no, absolutely not, Java is actually one of the fastest programming languages in the world, and you can compete with C and Go and C++ and other languages that are more, let's say, real time, in quote notations. Yeah. Okay, the next question is, do you think that Java is actually overrated? Yeah, it's a lot of, yeah, fuss about Java, but in reality, it's highly bureaucratic. It's a lot of code, a lot of XMLs, very complex projects. It's more like corporate C++, and yeah, now it's like it has roots in every company, and that's why we are actually using it still in the top, but it's actually not that great. It's just overrated, like inflated, like a bubble. Yeah, so you think that this statement is 100% agree? Do you agree with this statement? You think that is, yes, super bureaucratic and ineffective way to build software? And you think that is partially that this is slow and bureaucratic, but we need to use it because it's super secure and at least help us to manage the memory with the garbage collection or something like that? Or you think that actually it's not that, it's not overrated? It's just extensive. Yeah, maybe it's big and complex to learn, but it more or less is the same, like C++ with steroids or something like that. Or you are totally disagreeing. You think that Java is actually not overrated. It's still cool. It's not bureaucratic. You don't need to rely only in XMLs and complex projects and create all the structure by yourself. And maybe it's the best way to do OOP, object-oriented programming. Who knows? Okay. Last question is, how powerful do you think is the resource dependency in Java? Because one thing is to code, but the other thing is to deploy, to package, to release, to do the resource administration and so on. So many people can believe, yeah, okay, at the end, yeah, I can learn a lot of things, and I will create these thousands of gigabytes projects just to compile that, and someone has to deal with them, and it's going to eat the whole machine and so on. So you actually think that Java in this case is not needed? I mean, the resource dependency in Java and the way that we manage resources in Java is actually not that good, that we should find something else to do with this kind of projects. That dependency management in Java, for example, is null or not relevant for our applications. Or the opposite, you think that Java actually is the way not only to build software, but also to manage resources, dependencies, packages, control of memory, and so on. Do you think that is extremely powerful and is better than most of the other languages, programming languages out there regarding this resource dependency and management? Okay, so now I will open the poll and then we can start this discussion. Um, Launch poll. So right now we will have 2-3 minutes. No, not maybe, just maybe 2 minutes, because these questions are quite easy. Just click there. I will mute myself for 1 minute and then we will be back with the results. Okay, 20 more seconds. In the meantime, I will collect the evidences here so you can all see that. Mhm. Okay, so I'm going to finalize the poll now. Um, if you didn't have the time to vote, don't worry. It's just a measure for you to know, but for you to know the perceptions of the other people. But what I really want to know is that you remember your answers, and at the end of this conversation, or maybe in the next one, we can decide better if actually is even worse than we expect, or actually is something that we still should consider. Good. So here are the results. Um, you can see here the results. Also in your poll button, you can see them, but in case that you cannot, or for the sake of the recording, we will present them here. As you can see, the first question, how strong useful Java will be in 2025, then the majority of people think that Java will be still in the top 10. For the question, if is it heavy, people say, yeah, it's more or less like any other language, maybe twice as heavy, but not more than that. So it's not that far. It's overrated. This is maybe here more complete answer, let's say, between Java is not bureaucratic so far, but also it's not overrated, but it takes a bit more work to write, running, and code in OOP than any other language, OOP like C++ or something like that. So here maybe the number three is a bit not that unanimous. And number four is how powerful is the resource management and dependency. And again here, 50% think that it's extremely powerful, and 42% thinks that yeah, it's convenient, but quite simple, and it's easy to do it manually. Good. That's very interesting for we all to know. So let's continue here with when we should consider Java, or in general, what kind of paradigm we should consider. So we need to remember from our previous conversations and conferences that this software is not that easy as it's seen, like as many other people expect from outside the bubble, let's say from outside the house. The people think, oh, software industry is just pink, it's super easy. The people just sit there, smile, and code, and then code from 8 till 4, and then they are free, and then everything goes smoothly. But we know that is not true. We know that there are software crises since always, and this you can see that in the previous version lectures. And one of the reasons we need to bring this here is because you need to not be naive. You need to recognize what kind of projects do you have in front of you before deciding if Java or if any particular language is relevant for you or not. You have to know first what is your team able to do. Yeah. What are the theories that are already there? What are the libraries that are already stable? What is the support of the community, academy, companies, and so on? There are plenty new languages that look way more powerful than not only Java than the classic ones. But this has always happened over and over and over, and after 1 or 2, 3 years they die because no people invest in them. And it's not technically only. Sometimes it happens that the frameworks are just created and someone absorbed this company, or the company just bankrupt, or something happened, no one invests in the framework, and then it dies, and that's all. Maybe technically it was good. So you have to know what is the capacity of your team. How good is your team regarding a paradigm? If you are all structure programming language specialists, and then you want to switch to aspect or functional or oriented, maybe it's going to take more time. So maybe you should stick to a language that is closer to you. Like if you're working, for example, in forms, or these low code applications, and then you want to jump into Java, then I wouldn't recommend you that. Even if Java is or not powerful, this is not the case. So you have to remember that part, which are the functional requirements and the ability of your team. But you also have to consider this. Also, we mentioned in some other conferences, you need to also to consider um, what is happening behind the curtains. So how strong is this code that you are building? How strong is actually the process to deploy? How protected is the information? And in general, it's not only that it looks nice and runs pretty in front of the end user, but how safe is the end user with this application? How much can we rely on the module or on the container? How easy it is to hack, or how visible it is for hackers, for let's say negative hackers, of course, um, or cyber criminals better than, yeah, because hacker is something different. Another thing that you need to consider is the principle garbage in, garbage out. It doesn't matter if it's Java or PHP or Ruby or C Sharp or whatever. If your group is not using the right library or is using using that totally wrong, like trying to force, I don't know, some structure paradigm inside of the one class, and then trying to use as an structure, for example, in C, and then you're doing a lot of bad practices and, yeah, the anti-patterns, let's say. So you need to remember that each programming language is not going to do magic. So it's garbage in, garbage out. Like if you code something that is not, let's say, technically good, then Java is not going to do magic for you. It's going to be a disaster of application as well. This sounds logic, I know, but if you have been working in the software industry, you know that what I'm talking about, this is happening most of the time, and it's still happening. So for those who have not been in the industry or don't have the work experience yet, you can see this presentation a couple of years ahead, and then you will understand everything about garbage in, garbage out. Good. And maybe the last point to mention here to why select a language is the premise of done is better than perfect. So many people try to use always the most trendy thing just because they want to have the perfect solution, but they don't see the whole picture. And then we have this every day, not only this year, not only with programming languages, we have that with now with artificial intelligence, and then it's quite common that everybody's trying to fix and solve and incorporate artificial intelligence in everything, or machine learning, or this or that language. So let's be careful about that. Let's understand our requirements, our approach, let's say paradigm of programming, our team, what libraries do we have, how much money do we have for that, how much servers, how is our process of building software, instead of just going for the trendy language. Mm, with that, then just get and follow a proper architecture before selecting the technology, and then the approach and the paradigm, the resources you have, and then you can finally have early decisions of what should be your programming language. And it doesn't need to be all the modules in one language, although it should be better if you don't mix many languages in one application, just because of the entropy. But in general, every bad decision that you do in early stages is going to cost you a lot, because when you will be already coding or deploying or packaging something actually this architecture cannot support, then you have to let's say you have to destroy all these blocks and return to the point where you can fix it, and this is going to be very, very painful. My best advice, and the advice of my colleagues that I have gathered and where we have gathered, is measure everything. Nowadays it's very easy. Maybe in the past it was very difficult to measure everything, but nowadays it's quite simple. So you don't need to have a person that is counting how many lines of code each developer is doing, how someone that is monitoring at what time the person is connected to the IDE, how when it's more productive, which libraries is using, how many um, how many what? Yeah, how many modules have been developed by a specific developer, how much of this code written is created automatically by the IDE or by the framework, and so on. Yeah, so we have another lectures that when we were actually checking, for example, the how to estimate software. Then you should use that information here to measure all the time everything. Remember when we were talking about PSP and so on? Then this is it. Like you can install, and not only install, you can set up your environment, the team environment, to measure everything. How often do you deploy? What is your sprint window, maintenance window? How big are your packages when you're deploying? How is the consumption of resources in each of the environments? Test, QA, development, production, and so on. I'm always mentioning these different conferences, not because this is the continuation on all of this, but because all of them are interconnected, and maybe it could be useful for you to go and check these videos in our platform. But this is totally independent, just for you to know. I'm seeing here in the chat. Good. So things that we need to consider before going to Java: the duration of the project, the budget of the libraries we are going to use to train our team, how what kind of performance are we actually looking for. Is this a real-time application, or is more oriented to mobile? Maybe it's not that needed, but it's a standalone application. What is the amount of errors or the prone of errors that the user is able to accept? What is the time distribution? How can we manage the work in progress? How easily is for us to estimate projects? So if you have been working in a paradigm that is totally different than object-oriented programming or functional programming, or something like that, and you have been also working with a programming language that is not, let's say, Java, C, C++, Kotlin compliant, that they are more or less with the same similar keywords, then it's not that easy for you to start to do estimations in this new language. Yeah, if you come here from Fox Pro or Basic, not Visual Basic, but Basic, or I don't know, from any other language, and then you try to do the estimation here, it's not gonna work. I have seen that error in different projects. Some people say, okay, so usually do 350 lines of code in this particular project in Fox Pro, so I guess in Java, blah, blah, blah. Yeah. There are actually some websites that claim that, oh yeah, don't worry, if it's 100 lines of code in whatever, in Fox Pro, then in Java is 3x, so it's 300 times. But these estimations you cannot do. You have to start to train your people, start to build your proof of concepts. I don't know. Yeah, you can use this as a reference, but you cannot believe them like a true that is immutable. You have to have your way to do the estimations, and remember this, that you can always, let's say, be more accurate in your estimation, but it will be more expensive for your project to wait to specific points. Of course, you can always re-estimate. That's what we claim, but yeah, that's all. What else do we need to know here? That the programming language is not going to fulfill your problems if your team is not involved, and even worse, is not committed. Then maybe it doesn't matter that you have a good programming language, because at the end, garbage in, garbage out. So one of the things that I can tell you is to, if you are actually leading a team, you are the team lead or something, is protect your technical people, your techies, because the time of them is very valuable for them to be wasting in things that are not, let's say, technical. If they are having difficult times just trying to get the library, the license of the library, they don't know where to get the training, or they are just trying different programming languages at the same time in your project, then your project is going to suffer this. How do you call that? Yeah. Yeah, it's going to be the spend of energy in your project will be higher than the result or effort. Okay, saying that, then we already have covered the first time. The first reason is understand your project, then understand your paradigm. This I will continue better in the session, in the lecture number 2, when we focus in a specific paradigms, but more or less you know what I mean, because it's object oriented, functional oriented, aspect oriented, structural oriented, like assembly mode and so on. But this is not the only thing we need to consider. We need to consider what is the powerful of our language. If you have been working with Java, then maybe you know all of this that I'm going to present here. But if you work in Java, then you say, oh, this language is too complex and too heavy and so on. Then you disconnect from this language for a couple of years and then you reconnect and disconnect. You can remember that for you at that time, Java represents thousands of lines of code, modules, modules and modules, classes and XMLs, properties, XML, more properties, um, create these jars and manifests and the war and the EJB in the year and the SAR and the different application servers where you have to deploy. It was not that nice. It was not that easy. It was very powerful still, Java, but for you as a developer was a bit traumatizing this experience if you did that like in the 2000s or 2005, something like that, and then you disconnect. Then let me tell you that you have not seen a lot of changes that have happened in the last 10 years. So right now, for example, we have a language that is up to date with the trendy languages. So Java is, in this case, is not just losing pace. Yes, Java is secure. Yes, Java is WORA. It means read only one and run anywhere. Yes, because it has a virtual machine, but we all know that for a long time, many of the new languages already have something similar. So actually the advantage that Java can run in Unix, Linux, Mac, and so on, Windows. Yeah, this is important, but many other languages as well. And there are many other layers. The fact that Java is not only based in XML, but also in JSON, or you can actually use annotations. This is also in other languages, but you have to know that here in Java, the language is evolving each year to incorporate more and more of these features. It was a time when Java was leading also in the, let's say, libraries and the way to build software, and many other programming languages start to copy Java. And I think that was good because then it means that Java was doing something great. But also some new languages are doing different things that are super cool, and Java did not have them. But now Java is also copying the best things of all these trendy languages. So let me tell you that things like flows, the way of doing polymorphism, inheritance, the way to create libraries, modules, the way to manage the properties, the information that flows between applications now is as good as in any other trendy language. You can see here, for example, the daemon operator here, which allows us not to rewrite every time the data type, and we actually create nice things like anonymous classes that we don't need to define the type that is created here. We can have like this wildcard, so we don't need to define encoding time or in development time which class is that one. We can replace that at any point. We can use the polymorphism here. We can actually use simple things as documenting our code directly into the Java code. For those that are new in Java, there is a simple way to create documentation for the code. And this way is just to, inside of the same code, you utilize the annotations for the Java docs. Then you can create the whole documentation for your application, and this documentation would actually look like this. Let me show you. This website here, this was not generated by a human, but by Java, based on the reading of your code. So Java can read your code, the documentation inside of your code, and the Java doc is called this. And through these annotations, it will create actually this website, this HTML with the definition of the modules, the packages, the classes inside of them, and so on. You can actually always check this information, and this is standard, so it would look the same for you. And this is useful because when you are going to incorporate new libraries, you also know how to read a library, an API. This, yes, the API, the documentation of the API. Yeah, good. Um, okay, what else do we have here? So, for example, you can use the many annotations, but just to give you here examples, you can use Lombok and then reduce the sets and gets and the constructors and some, let's say, utility methods that usually you needed to type or your IDE did for you, but now you can hide them thanks to the annotations. You can use, for example, deprecate and signalize that this specific part of your code will be removed or changed, or yeah, just totally won't be there in the next release, for example. You can actually now have a tool to analyze this application static usage of deprecate APIs, for example, and you can run it and see which is the most, what is the highest priority to update one project. Yeah. Um, you can go here to the journaldev.com. I recommend you this website very much because it's very simple to understand. But if not, then you can go to the owner of Java nowadays, which is Oracle, since some years, when bought from Sun. And the documentation is actually quite useful because you can see the new most important features of each of the different releases of Java. Yeah. So I'm not going to explain that in this session today, but I'm going to enumerate them for you to know. We will have in Java not only the arrays and the classic collections, because many people know that, but in Java now you can do something like parallelism, manage collections with the parallelism. You can use immutable collections. There are plenty of methods. I think if I can tell you something that you should Google is the amount of frameworks and libraries that Java has in the world that are tested and in production in real projects with big companies. It's very difficult to find in any other language. This is for sure. So in this case, for example, you have methods for immutable collections that allows you to quickly and easy, you see it's clean, the weight of code, and you can have very different features like shells to run Java instead of creating your main and the class and the manifest and the jar, blah, blah, blah. You can run directly into a command line, let's say, similar to this command line, let's say. Yeah. So you have a shell, and in this shell, you can run the Java specific methods. So you can test Java immediately. You can utilize different patterns and factory method and interfaces, modules, APIs right away. The IDEs are there for you to help you. I will show you that later. This, for example, this REPL, this JShell is now very trendy in different other languages, and it's quite useful to build software the same way. It doesn't matter the operating system. I find that something that you could check. Um, you can check that, for example, here we are doing a stream. And look, just open a terminal, a JShell terminal, and I create a stream. And I just parser that with a for each, so in the way of streams, and I just print the first four numbers. You see, I don't need it. I didn't need to create the class, the package, and blah blah blah, the main method, the static, blah blah blah. Just right away with the JShell. Another cool feature you can check is about parallelism and flow control. There are new ways to manage, and is finally not complicated. This is something that if you were playing with Java in the past and now you are playing with Java, you realize that it has changed a lot. Now the flow control is way more powerful, the parallelism as well, but it's not as complicated to learn as before. Before you need to be aware of the way, the notify, the synchronize, you need to be create your own monitor, semaphore, whatever, the muxers, blah, blah, blah. And it was a nightmare to do that by code. It was powerful, but because you were doing powerful things with your fingers, coding very strange things. Now it's very simple. Like you have, for example, these completable futures. You can say, okay, run this code, and then let's keep doing this other code. When you finish, let do this pop subscribe, like asynchronous method. Let's say, how is it called? Observable, and then you just call me when you finish the execution, and we will continue the execution here. So this is a delay executor. That means that you can run in Java in parallel in different threads, different sequences, and you can synchronize quite simple, even with timeouts. And this is as simple as one line. So you don't need to know now all the framework of controlling and so on. Yeah. If you're new in Java, don't worry. I will explain. I will give all the resources here in the presentation, and we will go in them later. And also, if in the chat you think, oh, you also forget to mention this cool feature or whatever, feel free to text me there. Um, yeah. So deprecated tips. Yeah, this also I mentioned modules. Now Java is not like before that. If you were running Java some years ago, you realized that the virtual machine was eager to eat your resources. There was like with this job with Chrome. Remember that there was a time. I still think is the time is still, but there was a time when Google Chrome was eating the whole machine just to keep your browser up to date and running. There was a time when the Java virtual machine was just bringing too many things to the class path that you say at the end of the day, I don't need any of this. So with Java modules, I will invite you to check this out. You can run only what you require. You can say, I only require a module that use this and that and this package, and I want to create this package or this package that I code myself as a module for this and that requirement. And that's all. You can do now modular JDK that allows you to have very small packages in a very small configuration of virtual machine that is light, is lightweight, is faster, it consumes way less resources. And now one of the reasons because you can have Java in mobile, in IoT and so on is because the modules are simply to create and lightweight. If you are using, for example, right now a cell phone that is Android, behind it is Java. Like most of the Android are running Java modules, and the creation of the interface with the operating system is actually most of the time based in Java in this case. If you like functional programming, um, you can have stream management here, and the stream in Java is super powerful. The APIs are really simple to understand, and there are thousands of libraries. Those who are doing data analytics, processing data and so on, that you say, oh, I need a real language, I cannot use Java for this. Let me tell you that here in Java you also have a way to manage streams and data very professional and in a high volume. And we have actually here Hadoop, TensorFlow, and so on. If you are thinking about machine learning, artificial intelligence, and so on, this is also features that Java can handle with no problem, with very good set of libraries and methods. The HTTP2 client now is way easier to manage, so you can consume web services here, WSDL, REST, it doesn't matter. You can consume actually resources in the internet quite easily without knowing how to parse her, I don't know, IO stream, then buffer reader, then the try catch, but no, not any of these. You don't need that anymore. You just can manage that all as a stream. Yeah. I invite you to check these Java streams. They are quite powerful. And now you can see that we can have or take advantage of doing Java streams because of the parallelism. Many people say, yeah, I prefer the classic stuff, not streams. I prefer to do the classic sequential and loops, yeah, for while and into sequential collections. But then you are missing two powerful things. One is the processor, this publish subscriber processor of elements, and the second is the concurrency. When you have huge and complex data to analyze or to process, Java streams is going to give you way more power into the processing than in the sequential approach. So I invite you to see this shift of paradigm from the object-oriented to the functional-oriented programming. You can actually, as simple as code the different, I will show you later, a stream. It's as simple as execute methods dot filter dot with list dot print. So you can actually concatenate these streams operation in a very natural way, just as the graphic is showing. The way that we manage exception, this was always exceptional in Java. Like it was something that many people like. Many people like that they don't need to print or debug inside of the code and control the errors and damage the business logic. People loved the way that Java was working with that. The problem was how to handle the resources that were open, the consumption of memory, what happened when it fails, how to close it at the end of the transaction. And there were some patterns, but the people need to remember that. Now we try with resources. It's quite useful, quite simple. As you can see, the code is just try and then the resources are managed directly with the Java by the Java virtual machine doing the auto closable, for example. This is what I mentioned about the HTTP. Here we are using that with the JShell, but you can see here that to map a URL, for example, in this case, and consume and just response, reply to one of the execution to request there, then you can just create an HTTP response, and then you can just create your body and response. You can create web services in Java just with 2-3 clicks, and the IDE is going to create this basic code for you, and you are only going to take care of the business logic. Yeah, as you see, for example, here in this example. Okay, I will show you more Java features, but so far, do you understand more or less what I'm presenting to you here? I mean, is it clear? Not only if it is clear how these libraries are working, but is it clear why I'm showing you these libraries, or is it good for you to know that Java is evolving in that direction? Is there any in particular that you would like to mention that maybe we have missing, or that you would like to say, oh, you forgot this super wonderful library that it has been the reason because I switched to Java? If yes, then please write in the chat, and we will continue that in the second discussion, maybe in 2021. We'll see. But for me, it's very important this feedback, because then the next session we will go a bit more in detail into this, and then we can just not show here, but explain what is going on behind. This is more for the people who have been working already in programming languages, and maybe it makes sense for all of them. But for those that are new, maybe it's like, what the hell is this guy talking about? So let me tell you that more or less what I'm trying to tell you here is that Java is evolving with also the trends of the industry, not only with other languages or programming languages, but also with what is relevant nowadays. We have a lot of big data to process. Java is evolving that. We need a simple way to develop software in a concurrent way with thousands of developers. Java is evolving to do that. There are plenty of IDEs that are going to help us in that case. Yeah. For example, for those that are new here, Java is managing the memory for you. You don't need to specify, actually, not even the data type. Now we have var, which is not always to use, right? But we have var, and then you don't need to concern about the data type, also not how much is going to cost you in memory. You also don't need to concern anymore your object if it's not needed. Should I remove it from the memory? You don't need to concern about pointers in your memory, any of that. Since always, this is not something new, but for you to know, the garbage collection is super useful in Java. And it's not as simple as you maybe remember from the 2000s. Nowadays, there are super well-tuned Java garbage collectors that I will recommend you to check, because this is one of the reasons, because no, Java is not heavier 3 times, 10 times, or 100 times than any other programming languages. There are actually, I will present you later, comparisons of performance in real-time applications. Java used to be the Internet Explorer, let's say. So it was not the fastest one, but now it's really good. It's at the same speed as C and C++, which are really, really great fast languages. Yeah, another features that we can see here. The string collections are amazing. If you want to parser text, big data text, perform calculations, operations, XLTs, transformation, patterns, queues, I really recommend you Java for that. The way to create the Java doc, as I mentioned, the interfaces, many people were criticizing Java because it has only one inheritance. Let's say the superclass, but actually through the interfaces you can do way more things like that. And some people used to say, ah, but the interface is just a way to obligate to have a public method, but no, it's more than that. Now you can have statics, private statics, you can have default methods in your interface. You can actually create templates with code inside of your interface, and then the interface will be just reused or used for the implementations you need, not for all of them. Yeah. So you can see here, for example, we have the classic public interface, but we have a static method here, and we can actually code that, and we can actually use that. So yes, we cannot have multiple inheritance, but why do you have to have do you want to have multiple inheritance if we can do such powerful things with interfaces? And it's going to be instead is going to be still under the umbrella of polymorphism. You can still use the instance of, you can use all the powerful of object-oriented programming based on interfaces, and the interfaces today nowadays are super powerful. Yeah. You can see we have default methods. We can have actually private methods if you want inside the interface. Yeah. It's really, really good. Processing. Yeah, you can process different streams and so on, but I'm talking here about the processing of your connecting to your operating system and perform processing operations with your system. Now, before we had these independencies of the operation systems, and that was good, but when we need to run a specific command, DLL, cron, some processing background, when we want to use these super functionalities that have the operating system, like PowerShell or the Bash or whatever, it was not that easy. But today is very simple with Java, and it's native, and it's transparent for the development. We are using now a lot of the functional programming, so optional is everywhere, and it's quite easy for you to understand. If you come from any other language that is functional, to jump into Java now is not traumatic experience. Okay, and just to finalize, maybe, yeah, because I can give you thousands of examples that Java, but I need to know more the context. I would like to tell you that one of the first things that you can try if you are new in the language is download one of the most popular, one or two or three if you want, of the most popular IDs, and check their websites. Have a lot of tutorials on how to do new cool things. So you want to do web services, if you want to consume a database, if you want to do a graph database, if you want to, I don't know, create a cron, a job, a scheduled job. If you want to create your e-commerce application, whatever you need to do, there are plenty of examples, and they are totally assisted by these IDEs. So you don't need to, oh, no, then it means that I need to know all these 100,000 examples that David gave here. No, you don't need to learn any of them at the beginning. My recommendation is just install the IDE, try the tutorials. The IDE is going to build for you the package, is going to compile for you, is going to create the syntaxes, check validations, setters, getters, constructors, everything for you. I'm not saying that this is the way to build code in real life, that the IDE is creating everything and you have no clue what to do. But you can always first start there, see it running, and then start to learn specific topics. Okay, what does it mean then, this particular library and so on? When you feel more comfortable, not all the IDs are specialized in exactly the same. So install one, two, or three. It depends also on what kind of project do you have, what kind of application you want to build, if you want to pay for some libraries or not, if you want to connect some systems or not, etc. Yeah. IntelliJ IDEA, for example, was not that good 10 years ago, but today maybe is one of the leading. So I recommend you to check all of these. Eclipse is the forever there. It's very good since always. Blah, 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 blah. Okay. And when you understand a bit better the libraries, and you don't need to know everything about Java, but when you understand more or less what you are doing there, check frameworks, and you will realize that actually among of the web frameworks, Java is involved in most of them. This is an old graphic, but I can show you a bit more popular graphic here. because here no one is using struts. But here you can see that if I check the most popular backend frameworks, most of them have something to do with Java, yeah? Directly or indirectly. And if you, even if not, let's say you are in the .NET core, if you're totally .NET, and one day you go to Java, you realize how similar they are. Even in the libraries, they almost call the same. So I really recommend you to check in Google top 10 frameworks, top 10 Java programming languages, top 10 ways to build software, top 10, and then you realize that Java is a good bet to do. You think, yeah, maybe I should start to do software engineering, or you are just out of the school or at the university and you're wondering, is it good to learn Java as my first language to start, or I should learn something easier? My advice is no, try to go with Java, because Java has plenty of tools and libraries that could be easier at the beginning for you to learn. Let's check here the chat. I also like Golang, as in Java we must know so many things. Yeah, that's true. That's one of the things that the good languages have that is not that positive, is that it's so huge that you need to know a whole universe. But we have frameworks for that are, let's say, hiding that complexity a bit for us. But we also need to learn the frameworks. So yeah, it's better to learn the frameworks that are hiding this complexity than to go directly to this complexity, in my perception. Yeah, so I agree with you. Annotations, the design patterns, these are clear. For this, I also recommend you to check our previous lectures. But yes, I totally agree with you. Do we have any other question here? For me, Java is evolving, it's changing with the time, accommodating to new solutions. Correct. So I agree with Christoph. Yeah, it makes sense here. Super presentation. Pam, 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 pam. Okay, so no other comments. Good. Let's continue. So if you check here, more or less when you check the language rank for the past years, you will see always the same pattern. Like Java is among always the same, the 10, top 10. But if you check C Sharp, C++, C, like if you check among the 10, if you want know one of these 10 that are not that is not Java, then you can always switch to Java, because the syntaxes and the way they are actually working with libraries and the way they are processing information and so on is not that different. Actually, if you go, for example, through C++ and C Sharp, is super similar to Java. It's like to learn, I don't know, Spanish and Portuguese and Italian. It's not that totally different. Yeah, it's not like going to Arabic, Polish, Chinese, and Latin. No, it's more or less the same language. So if you know already, if you not the same language, but the same syntaxes, if you already know one of the top, it's very easy for you to switch to Java. And if you're also starting from the beginning, go to Java. Even if you don't like at the end and you decide to jump to C Sharp or C or C++ or even JavaScript, whatever, then you will find plenty of similarities there. So I will recommend you that. Okay, that was more or less the discussion of today. I will open the poll now to just see the experience of this short discussion today. And then the topics that you want to extend, maybe we will see us in the next opportunity with the second part of this lecture, depending on the comments in here. So I'm going to relaunch the poll. Let me just save the results here. Now, please feel free and vote again. What do you think about Java, to see if something has actually changed? Do you recommend learning Java instead of Python as a first programming language for total newbies? It depends what kind of applications do you want to build. Python, if you don't want to learn 100% Python before switching to Java, then I will recommend you to go to Python a couple of weeks, get used to the language, especially if you're new in programming languages. So get used to loops, arrays, parsing strings, and so on. And then after a couple of weeks, you are still not mastering Python, but then you have some idea about the basics of programming, no matter the language, and then you can start to learn in parallel Java. Then yes, I would recommend you to do that. With the JShell and the IDE, you can start to do same basic proof of concepts, let's say, the typical, not only hello world, but the typical analyze an array, parser some strings, create a web service, consume a JSON file, export a XML file, these kind of things that are quite basic in Python and in Java, you can do in parallel and realize, oh, here is similar to Python. Oh, and then you start to check, oh, actually, in Java we can do this, and in Python they're not, or vice versa. Yeah. This is for M Cordas, it says here. Yeah, so you're welcome. Let's check the poll. Okay, I'm going to close the poll in 30 seconds. Okay, thank you very much. Then I'm going to close the poll and let's see the results, and then we just wrap up our conversation, and that's all. Okay. So here we have the results. The perception after the first session of Java is still relevant. So here, how strong or useful do you think it will be in 2025? Then 90% of the people think that Java will be still in the top 10. And it will be useful for every kind of project, not only legacy projects, and yeah, even with the new trends will be there. Good. Now, how heavy is Java? Then we change our perception. Now it's a bit better. Now 60% of the people think that actually Java has similar speed or weight than any other language of these 10 languages, of course. Here I would recommend you to go to the to the website, what's the name, javazone.com, and to even the comparison of Stack Overflow. You can see a lot of tests of speed in Java, and you will see how good is Java now, like in compared to the past. It's really amazing. I mean, this is really good for all of us that are in the community. Actually, also check Kotlin. I didn't mention Kotlin here because it's a conference about Java, but you can always check Kotlin, and in Kotlin you will find a lot of similarities with Java. It's worth to mention that you can learn Java and then Kotlin, which is cool. Actually, someone is actually saying at the same time that I was thinking this, that Kotlin is cool. Yes, I think the same. And still be in the JVM world. Yes, correct. So if you go, remember this IntelliJ idea. This is from JetBrains. They create this Kotlin, and Kotlin is highly connected with Java world because they create that based on this IDE for Java. So if you go to Kotlin, then it's very close to Java as well. And I also recommend that language. What I was mentioned that because of the comparisons in Stack Overflow. Yeah. Let's see the next one. Is Java overrated? Then we have also here an increase in our answer. Now less people think that it's overrated. Actually, the people think that it's not overrated. For 70% thinks that the Java is not overrated and it's just a bit more time for the developer to write the code and deploy and so on, but it's more just more than C++ syntaxes. So, I mean, Java is not C++ with problems, but it's more than that. Yeah. The number 4, how powerful is the resource management dependency in Java? Then we also increase here a bit the perception. We think that yeah, it's convenient, but it's maybe too simple. Maybe there are better ways to manage the resources and memory and modules and so on. So here, I think we need still to work on it. Maybe in the second presentation, we can focus on dependency management, try with resources, the auto close, the way that we actually evaluate the memory. Maybe it would be nice if we can see 2 examples running, one with flows, concurrent flows, and one with the traditional object-oriented programming. Like, with that, maybe we can have a new perception in here. Here I see Emmanuel question. I have a question. I would like to get a job as a junior developer, but I'm scared. Is it better to start as a software tester? Is it better to start as a software tester, junior software tester versus junior software developer? The problem with the software tester is that anyway you need to review code, but review code is not create code. I'm not so sure how good is this step via tester. I'm saying that is natural for me because maybe I started the other way around. I think I started to do testing after I was doing development, so it gives me more ideas, but I'm not so sure how natural will be going from the tester to the developer. But if the question is about the scare, yes, you can go first as a tester because tester needs to focus also in the business requirements, not only in the code. So you will have at least a distraction there. Yeah, I would say it's not a bad idea, but it doesn't need to be a one-to-one relation with the path to follow. You can also start as a junior Java developer and it's fine. From developer's perspective, I prefer tester with technical background than regular tester. Yes, of course. Yeah. So, but he's saying like a start. For started, he will start as a software tester and then migrate to developer. Yeah, because if he only start as a tester and stay as a tester, you will not have the full potential of a good testing. That is to be able not only to understand the code, but the libraries and the powerful of the solution. Yeah, so it will give you also more insight to the developers. It's not, I mean, it's good that you tell to the developer this interface is not running correctly and the user is not expecting that, but it's way better if you can actually say from the code perspective, this should be this library, or actually maybe consider here not to use so much resources, or consider the try catch with resources, or consider that one, or maybe let's create a test case, a test case for stressing the system with this library, with this framework. Like, it's easier for you to explain to a developer when you know what is developing. I started as a tester and it was very natural and smooth. As a developer, I immediately got advantage over other developers. Yes. Like this path is possible, like tester and then developer, or developer and then tester. The important is that you, or the preference for me will be that you do the 2 roles at some point, because it's more valuable for the whole team. When you go to Scrum, and then you will see that in Scrum, for example, the members are more or less replaceable because they all have knowledge, then I think it's a good way to do both. I worked as a JavaScript developer for 1 year, but I don't like the language, so I decided to learn Java. And that good decision. I mean, I'm not also super fan of JavaScript, but if you decide to learn Java, then it's fine. Okay. Good. What do you think of superset languages like Kotlin? Oh, we already talked about that. TypeScript. Wow, TypeScript and JavaScript. Wow, this is another discussion. Let's talk about TypeScript and JavaScript. Let's talk about the performance and why these superset languages are now useful, why the frameworks are getting the way they are getting. Because if you see, there are trends in the frameworks. Like if you check Spring, it's totally different the first versions and today, not incremental evolution, but it's totally different. And this has a reason. The reason that TypeScript exists, Kotlin exists, and that the frameworks are evolving in one way makes totally sense with the world nowadays. Actually, it will be some layer above that when the machine learning and in general artificial intelligence will be a bit more useful from the software development perspective. When machines start to help us to create modules, then we will have something else than the typical languages. But let's discuss that in the second session. Do you think they will overtake the main language? Yes, I think they will overtake. Not, I don't know if Kotlin and TypeScript will take, but this extra layer that I am thinking, or when we will not be the only one coding, let's say, or creating software, yes, for sure, these languages will overtake, or at least that's my perception. Okay. Good. Yes, someone says here, keep in mind that you can write actually front end with Java. So yeah, that's totally true. That there are plenty of things. If you want to go mobile, there is Java Mobile Edition. If you want to create distributed applications, you can always go to Java Enterprise Edition. Not J2EE because this is too old, but JEE 14, for example. If you want to go and use operating system things, you still can use all the processing things like OS operating libraries of Java. You can create your own modules, so you can actually create jobs, control resources of your operating system via Java, tools of monitoring. If you want to go even to IoT, you have Java for TV. You can create Java for microwaves. Then graphical interface with JavaFX. You can create web interfaces. You can still use your favorite front end layers if you want. You can use old school way of building web application as well, like JSF is not dead, for example. Yeah, JavaScript frameworks integrated to the front end with Java are super popular nowadays as well. I don't know. I think it's very promising. I know that Java is not perfect, but I'm very happy with the way that the community is evolving the language. Although the language is a huge elephant and monster, and you think that no one can move that, somehow the community always surprised me and moved that. So yeah, good. I think that's all because now the time is actually already 2 minutes.